So here we have next question as number 10, 5 raised to e raised to x into sine square x. I take this as y, so y equals to the given function of x. I differentiate both sides with respect to x, d by dx of y, d by dx of this given function. And from here starts the differentiating steps. So what is the first step? We have to recognize the function. Why to recognize the function? Because if I do so, then only I'll be able to apply the correct result. So what is this function, students? You can pause the video and check whether you can name it. You must name this function. The name of the function is check. We have constant as a base, and we have constant 5 as a base, and then e raised to x sine square x. This is in x, so it is variable. So constant raised to variable. What is d by dx of a raised to x? A raised to x is constant raised to variable type function. It is a raised to x into log a. So this function 5 raised to e raised to x into sine square x is also constant raised to variable. But then what is the difference between these two functions? Here you would say constant raised to variable, and the variable is same as this. See, check, you are differentiating with respect to x, and the variable here in the function is also x. They are matching. Whereas in this, what you notice, you are differentiating, though you are differentiating with respect to x, but the variable here is not x. You do not have 5 raised to x. You do not have 5 raised to x. If at all you had d by dx of 5 raised to x, what you would have written was 5 raised to x into log 5. That's it. It's over. But then here what you have? Here you have d by dx of 5 raised to f of x type, where f of x is this, e raised to x, f of x is this, e raised to x into sine square x. So yes, you can again pause the video. Tell me, what is d by dx of 5 raised to f of x? It is 5 raised to f of x into log 5 into d by dx of f of x. This thing is always there whenever it is a composite function of x. So we have applied it. So I'm applying this thing here. So 5 raised to e raised to x into sine square x, derivative is 5 raised to e raised to x into sine square x into log 5 into d by dx of e raised to x into sine square x. And when I come here, d by dx of e raised to x into sine square x, this thing now will remain as it is. For this, we will have no change till end. This is copied here. This log 5 comes here. But now I have to differentiate this part. E raised to x into sine square x is product rule, because you have product of e raised to x and sine square x. So u d by dx of v plus v d by dx of u. U and v are e raised to x and sine square x respectively. Then next what happens? Here, okay, and why do I put a bracket here? Because I knew whenever I apply product rule, it will get me two terms, and hence outside these factors I have, they are common for both the terms. So you have to put a bracket, because this factor is for the first term as well as for the second term. If you fail to put a bracket, if you fail to put this bracket, it would seem that it is only for the first term. So the bracket is necessary. Now sine square x, you know, sine d by dx of sine square x, earlier also we have done, it is variable raised to constant 2 sine x into d by dx of sine x, which is cos x. E raised to x derivative is same as this, and this gets you the final answer. 2 sine x cos x is sine 2x and sine square x here. E raised to x is there in both the terms, so e raised to x has been taken common. So 2 sine x cos x is written as sine 2x, and e raised to x from here and here is gone out. This is final answer. Then we have question number 11. Question number 11 here is e raised to x into sine 2x plus cos 2x. So I write this as y, and then differentiating both sides with respect to x. And then here what you have, students, this is e raised to f of x. This function is e raised to f of x. What is d by dx of e raised to x? It is e raised to x. And what is d by dx of e raised to f of x? What is d by dx of e raised to f of x? D by dx of e raised to f of x will be e raised to f of x into d by dx of f of x. What is f of x here? This thing which you have x into sine 2x plus cos 2x is f of x. So it has been done here. Derivative of this is e raised to x into sine 2x plus cos 2x into d by dx of f of x. Okay. Now you have derivative of sum of two functions. Check. Here you have sum of two functions. You are having sum of two functions and d by dx is outside. So what you will write? You will write d by dx of this. You will write d by dx of this and d by dx of this, which is written here. You can check. The first factor is copied as it is. Then then you have then you have x into sine 2x. When you write d by dx of x into sine 2x, it is product rule. So x into d by dx of sine 2x plus sine 2x into d by dx of x. You will notice that as we are going ahead, gradually the difficulty level of these problems are increasing. Okay, but I feel still it is very interesting, and if you know the basics, you just need not be worrying. And then d by dx of cos 2x. Students, look at this function. It is cos function, but look at the variable. The variable is not x. It is not d by dx of cos x. It is d by dx of cos f of x. It is d by dx of cos f of x. So derivative will be minus sine f of x d by dx of f of x. That is minus sine 2x d by dx of 2x. And then this is all simplification. You can check d by dx of sine 2x here. You will get cos 2x into d by dx of 2x. X d by dx of sine 2x. So d by dx of sine 2x is cos 2x into d by dx of 2x, which is 2. Sine 2x d by dx of x is 1 and minus sine 2x into 2. So this gets you, now this 2 into x is 2x, cos 2x and minus sine 2x. Why minus sine 2x? Because you have plus sine 2x and minus 2 times of sine 2x. So sine 2x minus 2 sine 2x is minus sine 2x, and this is your final answer. This is final answer. Thank you.